In this video, we are going to look at the concepts of elements and isotopes for chemistry. Now, after going through this video, you will understand the basics of elements and isotopes for chemistry. So ensure you stay to the very end of this video. Okay. Now, these are very, very important aspects of chemistry. So let's begin with elements. All right. So basically, what is an element? Now, an element is simply a substance that is made up of atoms that has the same number of protons in the nucleus. All right. So basically, elements consist of atoms with the same atomic number. All right. Now let's look at how elements can be represented with symbols. All right. Now, for instance, oxygen has its chemical symbol to be O. Hydrogen has its chemical symbol to be H. Sodium has its chemical symbol to be this. All right. Another example is iron has its chemical symbol to be this. Another example is lead has its chemical symbol to be this, Pb. Another example is zinc has its chemical symbol to be this. All right. Now another example is magnesium. Write it here. All right. So magnesium has its chemical symbol to be this. Okay. Now in this order. Now note that this odd symbol like this iron, lead, sodium, the symbols come from the Latin names of these elements. Okay. So this is basically what you have to know about elements. I know that combination of two or more elements chemically will produce what? A compound. Okay. All right. Now, having known this, that an element is a substance that is made up of atoms that has the same number of protons in the nucleus. All right. So basically, elements consist of atoms with the same atomic number. Okay, now let's wipe this and look at the concept of isotopes, all right, which is where you mostly see your questions under elements and isotopes for chemistry. So let's wipe this. Okay, now we are looking at the concept of isotopes. Now, isotopes are simply atoms of the same element having the same atomic number but different mass numbers. Now, a very popular example of a pair of isotopes are carbon-12 and carbon-12 and carbon-13. All right, so basically we have it to be something like this. So the atomic number of carbon is 6, the mass number here is 12. All right, for this carbon, the atomic number is 6. The mass number is 13. So they have the same atomic number but different mass numbers. Okay, so in this situation here, you can deduce that the proton number here is 6. The electron number is also 6. Now the neutron will be, when you subtract the atomic number or the proton number from the mass number, you have it to be also 6. That's 12 minus 6 will also give us 6. Whereas in this case, the proton number will be 6. The electron number will be also 6. Now the neutron number will be 13 minus 6, which will give us 7. Okay, in that order. Now take notes of this. All right. Now if you want to draw the structure of this carbon atom, so as we all know, carbon is made up of 6 number of protons. So this is a nucleus. The nucleus contains the proton number and the neutron number. All right. So the electrons revolve around the shell. Now this is a first shell. This first shell normally contains a maximum number of 2 electrons. All right. It doesn't exceed 2 electrons. All right. So we call it the duplet shell. Whereas this second shell and beyond, whether it's second or third or fourth shell, contains a maximum number of 8 electrons, and we call this the octet shell. Since carbon has 6 atomic number, so the first shell will contain a maximum number of 2 electrons, remaining 4. Alright, so the 4 you can fix it here. Alright, so this is the structure of this carbon atom. Okay, so take note of this. This is the nucleus containing proton and neutron. Okay, having known this basic information, now know that because many elements can exist as a number of different isotopes, all right, relative atomic mass, which is also denoted as AR, is used instead of mass number when referring to the elements as a whole. All right, so basically, let me wipe this and show you this formula. Basically, you can use this formula to work out the relative atomic mass of an element. All right, so we have relative atomic mass to be sum of isotope abundance, all right, times isotope, okay, mass number. All right, bracket close, over sum of abundance, okay, of all isotopes. All right, of all the isotopes. All right, so this is a basic formula that can use to calculate the relative atomic mass of an element, sum of isotope abundance, okay, times isotope mass number over sum of abundance of all the isotopes. All right, so let's look at the basic question on this and apply this formula to it. Let's write this. Okay guys, now let's look at this question under isotopes. So it says copper has 2 stable isotopes. All right, copper 63 has an abundance of 69.2%, and copper 65 has an abundance of 30.8%. We asked to calculate the relative atomic mass of copper to 1 decimal place. All right, so for the relative atomic mass of copper, we are going to apply this formula: sum of isotope abundance times isotope mass number over sum of abundance of all the isotopes. So basically, this is going to give us, when you apply the formula I showed you earlier, it's going to give us 69.2, okay, times 63. All right, so this percent abundance times the mass number of this copper here, all right, plus, put it in brackets, this time around, the percent abundance of this copper here, 30.8, all right, times the mass number of the copper, that's 65, over sum of the percent abundance of the elements. So we're going to have it to be 69.2 plus 30.8. okay, so when you simplify this on a calculator, you're going to have it to be, let me simplify the numerator. Okay, 69.2 times 63, you have it to be 4359.6. all right, plus now 30.8 times 65, we're going to have it to be 2002 over, now when you add 69.2 plus 30.8, we're going to have it to be 100. All right, so when you break this down, everything, let me punch it in the calculator. Okay, so we have the value to be 63.616. But remember, we asked to leave our answer in 1 decimal place. Okay, so to 1 decimal place, the value will be 63.6, and this will be the answer. Now note that relative atomic mass does not have a unit. So take note of this, does not have what? A unit. So having known this, let me give you guys a practice chemistry question on this topic. And after you can call it a class, let's wipe this. Okay guys, now look at this chemistry practice question. It says an isotope of iron has a mass number of 56 and atomic number of 26. Give the number of protons and neutrons in an atom of the isotope. Alright, so feel free to pause this video and see if you can figure this out. This is a very simple question, guys. Okay, let's do it together. Now for the number of protons, alright, protons will be, now proton number is same thing as atomic number. Alright, so the number of protons will be, since the atomic number is 26, will still be what? 26. Okay, now for the neutrons will be to subtract the atomic number from the mass number, which will be 56 minus 26, so which will give us what? 30. So it's as simple as that. This is the neutron number, this is the proton number. Okay, so let's start the class here, guys. Hope there's something interesting from this video. Now, if you are new to the channel, ensure you check the description of this video below for link to our Telegram channel. Click on it and join the Telegram channel for instant notification. Also, ensure you subscribe to this channel for more videos like this. Like, share, and comment on the video. Tell me how you feel from what I learned from this class. If you seem to have any specific questions asked regarding this topic for chemistry, feel free to leave a question in the comment section below, and I'll be sure to give you a response. That's it for this class, guys. Thanks for watching. Now click on the end screen above, and I will see you in the next video.